Hello and welcome to SciLux, the podcast where we talk about scientific developments and technological changes in Luxembourg. And in today's episode, we are going to focus on space. We'll have a look at ultra-lightweight structures, antimicrobial coating. We will talk about space resources, as usual, of course, in this program when it comes to space. There'll be something about lunar resources this time. There'll be Space Loop, so a new program allowing us to communicate using satellites. And we will mention something about the upcoming Space Resources Week in Luxembourg. And last but not least, superconductive magnets and a safer entry to atmosphere. But first, as usual, it's time for the pub quiz. As you know, hopefully, this is the part of the podcast where I give you one pub quiz style question, and the answer to this question is at the very end of the podcast. Today's question will be very short, so listen carefully. What is ISRU? So what does this abbreviation mean? And as I said before, at the end of the podcast, I will give you the answer to this question. I spent a couple of months collecting information about space in Luxembourg, and today's episode is the effect of this collection. So first of all, I wanted to tell you something about ultra-lightweight structures and why they are important when we discuss going to space. This is research done by LIST, so the Luxembourg Institute of Science and Technology, together with the company Gradle. They decided to work on a technology which is called XFK in 3D. It's a groundbreaking technology that allows us to turn some of the parts taken to space in satellites from metal into these lightweight structures. We're talking about carbon fiber that is coated with a polymer. And what we can hope for is about 75% less weight to be taken into space. This is really crucial. And I guess that's why also there is a lot of interest from big companies, European giants, when it comes to satellite construction. We're talking about Thales Alenia Space and Airbus Defence and Space and OHB from Germany already showing interest to use this technology made in Luxembourg in cooperation with Gradle, which is also a Luxembourgish company, as I said. What is planned for now are two different parts of the project. We're talking more about the artisanal part, where it's going to be all handmade, and then we are going to move on to a robotized project, where recently installed robotic arm is going to take care of the construction. So hopefully some improvement when it comes to weight taken to space. If you remember, there's been a lot of discussion on how much it costs to actually bring certain things to the astronauts. I guess you've seen them in different costumes, playing musical instruments. I've found some very interesting summary of the costs of these whims, if you want, how much it costs to take them to space. I will share the link, of course, as usual, in the show notes. And now on to antibacterial coating. Yes, I'm not going to talk about the virus. I don't want to talk about COVID, as I said already many times during this podcast. So this time we're talking about the safety of astronauts, and to be exact, a way to protect surfaces from bacteria or parasites. And again, LIST, led by David Dudet and his team, has managed to develop some new non-toxic surface treatments. They so far have done the treatment of 30 by 20 square centimeters, so that's about the A4 piece of paper size. They're planning to work on also 3D objects in the future. What is important right now is that they can really lower the amount of bacterial activity on the surface by about 6 levels of magnitude. So we're talking about 100 million bacteria to 100 bacteria. And this surface was developed in a cooperation between the chemistry, materials, surface treatment, analysis, durability tests, microbiology and toxicology departments at least. So quite an interesting interdepartmental cooperation. The result is a surface that is able to inactivate two major families of bacteria. We're talking about gram plus and gram minus, so the ones that cause many infections. And the plan now is for the same surface to be resistant to fungi and yeast. So we are talking about fungi of type A Niger. That's kind of black mold that you can remember from forming on certain fruits or vegetables. It's a very common contaminant, and also yeasts of type C albicans. It's a typical yeast used in research. It can be found in human gut flora. First of all, A for paper, and from that, resistance to other pathogens. The third story of today got me very excited because at the very end, the person interviewed in the article I read, Dr. Jan Thommel, talked a little bit about Star Trek. So that was a very nice comparison. But before I get into that, imagine this moment when you are responsible for a Mars lander or any kind of spacecraft. This spacecraft is supposed to land, and for 7 minutes, you have absolutely no communication. You have no clue what is happening. And this is exactly what many people involved in such landings go through. This happened to re-entry capsules, the space shuttles, and of course Mars landers. So we call it blackout. And this is this moment when everybody is really keeping their fingers crossed, or rather almost dying, because you never know whether the landing was successful or not. And the reason for that is that when the spacecraft enters the atmosphere, it goes through certain plasma, and that plasma really influences the ability to communicate. What the team led by Dr. Jan Thommel has tried to develop is an application of a superconductive magnet. And this magnet is supposed to let us communicate through the plasma and also make it safer for the landers and other spacecrafts. This is already a tested technology. The current model, which was produced by NASA, is not very good. It has some fundamental flaws, and the teams were able to validate their concept during the last robotic mission to Mars, the ExoMars, and it seems it worked very well. So Dr. Thommel, together with a PhD student, Dr. Juan Merlano Duncan, are now working on a special modeling and together with other universities, so University of Leuven, Karlsruhe Institute of Technology, von Karman Institute in Belgium, and the University of Stuttgart, they are going to develop this technology. We are also talking about the very important and extremely tricky part, so creating and containing the plasma so that the whole model can be tested. And that's not done in Luxembourg, unfortunately, nevertheless, part of the project. And yes, they are hoping to influence the way this all happens when spacecrafts enter the atmosphere. Why did I say Star Trek? Because Dr. Thommel compared this superconductive magnet to a deflector shield. And now a piece of news that most of you have probably heard of, but I am also hoping that there are those ones who kind of missed it, because it was the end of last year when we got to know that one of the Luxembourg-based companies has been chosen by NASA to collect space resources and transfer ownership to NASA. So not bring it back to Luxembourg, unfortunately. We're talking about the lunar outpost of Golden, Colorado, the Marston Space Systems of California, and then iSpace Europe, which is based in Luxembourg, and iSpace Japan in Tokyo. What is interesting in this whole mission is that we're talking about the ISRU here, and I'm not going to tell you right now. And it is a very crucial, vital role for the future human missions to Mars. These 4 companies were chosen on the basis of the so-called lowest price, technically acceptable offers. We are talking about this low-cost lunar resource collection program, which means it kind of reminded me as if like Ryanair going to space, so kind of a cheap way to get the resources. And it's a bit of a interesting synergy, if you want, because the idea is that these companies will collect a small amount of lunar regolith from any location, so they can choose where they will go on the moon. They will provide the images of the collection and the collected material, and then also the exact identification of the location. But they will then transfer the ownership to NASA. So kind of like, oh, look, I found this, it's here, this is what I think it is, but this is yours. And also what was another interesting fact in this whole program is that one of the companies proposed to be paid only $1. Of course, I had to check why. And this company, it's the Lunar Outpost, they're planning to go to the moon anyway. So they said, oh, we might as well just provide something for NASA. The other companies actually asked for $5,000 for that, or even $15,000. So quite a difference, I would say. So of course, with iSpace, we are excited. This is a Japanese company, but they decided to base their activities in Luxembourg when it comes to Europe. They were founded in 2017. They are part of the science team for Prospect, so the ESA program, which seeks to extract water on the moon. And they're also planning to build a small commercial lunar lander, which I guess will be part also of the lunar resources collection program somehow. And last but not least, Orbitare, a startup based in Luxembourg and Switzerland, decided to cooperate with Spire Orbital Services, and they are planning to launch a communication application called Space Loop. So the idea is, of course, better, faster communication anywhere you are using one of the nanosatellites of Spire's. The plan is to have 2 demonstration missions which will validate the communication protocols, one in April, so very soon, and one in June this year, and then further expansion, of course, of the whole idea. I am very curious about this project because Orbitare claims to try to find and develop applications of space with a large and positive impact on society. So I'm waiting for that impact. And now it's time for the answer to the pub quiz. So if you remember, my question was, what is ISRU? And that is in situ resource utilization. So I mentioned it a couple of times today, not directly, obviously, but the idea is that it's the ability to generate products with local materials. So instead of bringing everything from Earth, we are actually using the resources we find on different planets, or in this case, Moon, in order to be able to go for deep space exploration. We are already using the available sunlight. The future would be using water, being able to grow plants, somehow extract, combine, create fuel, maybe breathable air, some way to propel our rockets, and find some building materials. So this is quite an exciting and new area of development, and very important also in the coming discussion that is going to happen in April, to be precise, between the 19th and 22nd of April this year. We're going to have the Space Resources Week in Luxembourg. It's going to be a 4-day, unfortunately, online conference, and it's supposed to unite leaders when it comes to the terrestrial resources sector, airspace industry, financial institutions, research institutes, academia, all to discuss ISRU, which now you all know what it is. Also, it's supposed to lead to elaborating some recommendations, how to develop this technology sector and how to move forward. So as I said, this is the 19th to 22nd of April. You can already register, and it is organized by ESRIC, so the European Space Resources Innovation Center, based in Luxembourg, in collaboration with ESA, and LSA, so the Luxembourg Space Agency. A couple of more pieces of information that were recently found on the web. First of all, I don't know if you've seen, but ESA is looking for new astronauts. So I had a question a couple of months ago about the only possible Luxembourgish astronaut, or rather a person who could go to space, but maybe there will be more. Who knows? So if you want, you can already apply for one of the posts. We are talking about 4 to 6 candidates to be part of the as an astronaut corps, and then there will be up to 20 who will go into reserve. So quite a lot of different people who can actually get to work there. They're also looking for one or probably even more para-astronauts. So in case you're interested, I will share the link in the show notes. And who knows, maybe thanks to that information today, your life will change and will become an astronaut. And of course, another important information, a little bit more related to Luxembourgish soil. Remember, I told you about Meluxina, so this supercomputer based in Luxembourg. And now it's just opened a call for early access. So you can get a free access to the supercomputer to do your calculations, to use it before the official start, and the applications can be sent until the 19th of March. So hurry up, because that's not a lot of time left. And yes, that's the end of today's show. I hope you enjoyed it as usual. Whenever there is space involved, I'm always very happy to tell you about all the different developments in Luxembourg. And of course, remember that this podcast, SciLux, is also about other scientific developments and research in Luxembourg. Don't forget to follow us, to subscribe, to check out all the different information on Twitter, on Facebook. Contact us if you have any questions or comments. And yes, until next time. Thank you. My name is Hanna Siemaszko, and this was SciLux.